Question 8 is quite an involved question, but as long as you take it carefully, it should be fine. The graph of y equals f dash x between 0 and 5 on the x-axis is shown in the following diagram, and you're given the intersections, which are labelled on the diagram, and the local minimum, which is also labelled on the diagram. You're asked to write down the x-coordinate of the point of inflection of the graph y equals f of x. So you know that at a point of inflection, the gradient goes from increasing to decreasing, or from decreasing to increasing. That is, the gradient of f of x is going to be changing. So if we look at this, the gradient of this graph goes from being negative, 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 to positive, 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 positive. So it must be at this point here, x equals 3, that your point of inflection lies, because the gradient of the gradient, f double dash of x, is going from negative to positive at that point and nowhere else. You're told the shaded area enclosed by the curve y equals f dash x, the x-axis and the y-axis is 0.5, that's this shaded area here. You're asked to find the value of f of 1, so I know that the integral of f dash x dx within the limits of 0 and 1 is equal to 0.5, so that gives me f, because if I integrate my derivative I get my original function, f of 1 subtract f of 0, fundamental theorem of calculus, is equal to 0.5, and so f of 1 is equal to 0.5 plus f of 0, which is 3, so is equal to 3.5. Part C, the area enclosed by the curve y equals f dash x and the x-axis between x is 1 and x is 4 is 2.5. Find the value of f of 4. So, the trick here is to notice that your area is below your x-axis, and therefore your integral between 1 and 4 of f dash x dx is actually going to be equal to minus 2.5. Now, the first time I saw this question, I didn't spot that, and it does become obvious in part D when you sketch f of x that your other answer couldn't make sense, and I'll talk about why that is when we get there. So therefore I know that f of 4 subtract f of 1 is equal to minus 2.5, and so f of 4 is equal to f of 1, which we found to be 3.5, minus 2.5, so f of 4 is equal to 1. Part D asks me to sketch my curve between 0 is less than or equal to x less than or equal to 5, indicating clearly the coordinates of the maximum and minimum points and any intercepts of the coordinate axes. So I'm going to do that on my second sheet of paper over here. And I basically am going to begin by using all of the information that I have so far been given. So, I don't know anything about my y-axis just yet, but my x-axis I know I want to go up to 5, and I'm going to try them very roughly, because it will help me visualise this, demarcate my x-axis into these steps. You wouldn't have to do that, however. And I know that f of 0 is equal to 3, so the first thing I can do is put f of 0 equals 3. I know that f of 1 is equal to 3.5. I also know that f of 4 is equal to 1. Let's say, there you go. That's 1, not exactly to scale, but we're doing all right. I also know I have a point of inflection at x is 3, but I don't know where that is yet. So I want to consider the nature of these points here then. At x is equal to 1, my gradient is going from positive to negative. Positive to negative must be a maximum value, so I know that I've reached a maximum of some description. And then at 4, my gradient is going from negative to positive, a minimum value. And all I have in the middle is a point of inflection. I've drawn this a bit too optimistically, but a point of inflection at x is equal to 3 to get to my minimum. Now this is crucially where I could find out part C is incorrect, because if you use your area or your integral is plus 2.5, you get f of 4 is equal to some large number above here. So f of 4 would be up here. As soon as you've reached a maximum and then nothing until 4, that would be impossible. So that's how you could self-check your work. I'll then just make sure I've labelled everything, so this is my minimum. and I have that at 4, 1. This is my maximum, and I have it at 1, 3.5. I've already labelled that intersection, so that's fine. This is my point of inflection. I'm just covering myself here at x equals 3. I don't know my y value. Don't need to know my y value. And I'm done. So if we look at the mark scheme for this, part A is just writing a number down. Part B, attempting to use definite integral, and then fairly straightforward argument to get to 3.5. Part C is again the same argument, but you get 1 mark for using minus 2.5 as your area, and then 1 mark for, therefore f of 4 is equal to 1. No marks for the method because you got those in part B. And then part D is for some relatively accurate sketch. Correct shape over approximately the correct domain, that's quite important. Maximum and minimum points, I've written those on, so there's no ambiguity. And 1 for the y-intercept, which was given in the question. And so actually, 9 marks, that's pretty nice for this question. Onwards.